Hi, I am Guusje from Skytree, a company that builds technology for the direct air capture of CO2. As you probably know, we have too much CO2 in our air, and this CO2 causes climate change. However, ironically, we also have too little CO2, because CO2 can actually be used for many industries. So, what Skytree does is building equipment that can capture CO2 and release it again to customers that can use the CO2. For example, for utilization, like plant growth, or it can be sequestration, you name it. So, today I'll be explaining a little bit about the Skytree technology in general. What I have here is a Skytree demonstrator. On the left here I have a balloon that I just blew up. As you probably know, when people breathe out air, there's quite a lot of CO2 in it. I press this button and the air from the balloon is going to be transferred to this chamber here to the right. You see on the back here two detectors. One of them is for CO2 and one of them is for relative humidity. Because the detector has now detected that there's too much CO2 of the air, it switches on the filter technology. Because the air is passing through the filter, the CO2 is now being captured. You can also see that again on the screen, that now that the filter is working, the ppms once again go down. And that is essentially, in a simple way, Skytree direct air capture technology.
Welcome to Skytree's webinar, The Future of CO2 Supply. We're very excited to have you here today, and we're excited to share a little bit more about our direct air capture technology and its application specifically in indoor agriculture. My name is Camille Hanna. I'm Skytree's Business Development Director based in North America, and I look forward to walking you through a little bit more information about how this can benefit your operation. Please make sure that you also save your questions for the very end of the presentation. Write them down as I'm going through the presentation because we want to make sure that we can address them at the very end. So to kick things off, just to introduce the company to you, Skytree is a Dutch company, so we're headquartered in Amsterdam, Netherlands, and the technology that we manufacture was actually born out of the European Space Agency. So it was developed to pull carbon dioxide out of the cabins that astronauts are in, which is pretty cool. And it's now has an application in the controlled environment agriculture world. We have a lot of greenhouses right here in our backyard of Amsterdam, and we are eager to deploy it in many more indoor agriculture operations across the world. So Skytree is set out to transform the way that CO2 is used right now in indoor agriculture. It's a very unsustainable practice at the moment. We do see that a lot of indoor farms typically use CO2 to basically increase the yield of their crops. By adding CO2, you can increase the yield by 20 to 30%, so it's a very important input. But there are lots of challenges that happen within the current CO2 supply. Not only is it unsustainable, but costs are very high and there are often shortages that are experienced. So if we actually zoom into what the CO2 landscape looks like in indoor agriculture, we see that it normally comes from two different sources. Either it's coming from natural gas that's burned on site, or it's coming from point source capture. So for example, a large oil emitter might be giving off carbon dioxide in their manufacturing process. And what happens is that CO2 can be captured. It then has to be purified, which requires energy because there are a lot of impurities in that CO2. It's then liquefied and then it's put on a truck, and that truck drives to the farm. It sounds like it's a great process. What otherwise would be going into the air is now actually going into an agriculture, facility. But what actually happens in that process is that oftentimes additional emissions are created because it requires energy to purify, liquefy, and drive the CO2. Not only is that currently what's happening, but what we're seeing is actually with a lot of these large emitters, they're starting to divert their supply to be stored permanently. And the reason they're doing that is because they can then claim emissions reductions. So we anticipate that that is going to continue to happen over the coming years, and CO2 will actually not be as widely available as it is today. And normally when that happens, oftentimes the prices of the CO2 will raise, and we certainly don't want there to be issues at indoor farms, not being able to receive their CO2, which is a very important input. So by looking at, kind of the full picture of how CO2 is used today, there's obviously a lot of challenges, and we think at Skytree that there's a much better way of doing this. And the way that we believe that this can be done in a more efficient way is actually through direct air capture. And by actually having a direct air capture unit on site at your agriculture operation, you no longer have to rely on third parties to bring that CO2 in. You're not burning fossil fuels to create the CO2. You have a unit that is there on site that can produce CO2 whenever you need it. It's on demand. You don't have to worry about price volatility. And ultimately, it is much better for our planet. So when you capture the CO2 using direct air capture, there's typically two things you can do with it. You can store it permanently, which is done in many industries outside of controlled environment agriculture, or you can capture it and utilize it, such as in a controlled environment agriculture environment. And the way that direct air capture works is you have a unit, and within that unit you have a filter. And that filter has a solid sorbent on it. And what happens is as you pass air across that filter, the CO2 sticks to the filter or that solid sorbent. And once you're ready to release the CO2, you have to heat that filter up. The CO2 gets released and it gets put into a buffer tank. And that buffer tank can be used by the grower whenever your operation needs CO2. We actually have two units available. Our smallest, meant for vertical farms, is a Cumulus unit, and it produces 20 kilograms of CO2 per day. On a much larger scale, we have a portfolio of Stratus units. The smallest Stratus unit produces 500 kilograms per day, and it is actually a hybrid unit, meaning that it runs off of both electricity and thermal energy. So if you have waste heat available within your greenhouse, you can actually utilize that to bring energy consumption down pretty significantly. Not to worry if you don't have waste heat available, we actually have two all-electric Stratus units available. The first being 750 kilograms of CO2 per day. That's about the size of a 10-foot shipping container stacked on top of one another. And then our electric 20 unit is 1,250 kilograms of CO2 per day. And that's about the size of a 20-foot container stacked on top of one another. The wonderful thing about our units is that they are really built to scale, and they are modular. So if you need 60 kilograms of CO2 per day, you can stack 3 Cumulus units on top of one another, and same with the Stratus units as well. Once they're installed, you can very easily attach it to your existing CO2 dosing equipment. So for example, if you had a canister attached to your dosing equipment, you can just take that canister out and attach our buffer tank to that CO2 dosing unit. In addition to the installation, once it starts running, we actually are able to fully remotely monitor the unit through an IoT connection. And this allows us to make sure that the unit is running as we promise it will, that it's producing the amount of CO2 that we promise it will, and that ultimately if something goes wrong with the unit, we can actually tell before you can, and we can have someone there on site very quickly to be able to fix the unit. Up next, we're going to be showing you one of our Cumulus units on site at the Wageningen University. This is a leading research university based in the Netherlands, so it's very close to our headquarters. And you'll get to see the unit in action here with actually one of the representatives from the Wageningen University and our business development director based in the Netherlands, Fred.
Direct air capture is an interesting technology that could be an alternative source of CO2 not only for greenhouse horticulture, but for other sectors. Our partnership with Skytree started with Kassels Energiebron, which commissioned us to do a project on CO2 from direct air capture for greenhouse horticulture sector. But Skytree was already ready to deliver a machine that's able to produce CO2, and now we're able to test it here in Blijswijk.
The Cumulus unit is the smallest version of the direct air capture equipment that we design and produce, and I'm excited that we have an opportunity as being the first one with this technology to be present here and to run those trials.
I get very excited because it could help us towards a more CO2 neutral sector.
So one of the questions that you might be asking yourself, or you will ask me at the end of the presentation, is how does Skytree's direct air capture carbon dioxide compare to traditional CO2? And that question does depend on, a couple of different variables, what you're paying today, for example, what your electricity costs are, and we've actually developed calculators to be able to very easily analyze this for you. In this case, we wanted to just give you an example of one of our partners in Spain. Their name is Nebota, and they grow basil in vertical farms. So when we initially met with Nebota, we reviewed some of their, traditional CO2 supply numbers. And what we were able to realize through our analysis is that by Nebota switching to direct air capture using one of Skytree's Cumulus units, they will actually realize a 79% reduction in cost. So it will go from €2.88 to 62 euro cents per kilogram of CO2, which is a really significant saving. And we're very proud that they're one of our pioneer customers. And we really hope to, expand these results to additional indoor farms all over the world. So we are actively selling our Cumulus unit. The units will be available for delivery starting this summer around the July timeframe, and you can sign up now for a Cumulus unit. Our Stratus units will be available at the end of this year, starting in Q4, and we're also seeking partners for that unit as well. So please, if you're a vertical farm or an indoor farm, a greenhouse, we're very open to having a conversation with you. We'd love to determine how our direct air capture units can be implemented into your operation, and we look forward to hopefully working with you in the near future. Now I'll pass it off to Guusje, which will be she'll be going through an overview of the technology at a much deeper level and the future of DAC.
Thanks, Camille. I'm Dr. Guusje Delen, and I'm here to talk more about direct air capture from the more technology perspective. I am actually part of the research and development team here at Skytree. I joined about 2 years ago as an R&D scientist. Now, my background is in chemistry. I have a PhD in that as well, and that's why I've been looking mainly at the sorbent material. The sorbent material is very important for direct air capture. You need to make sure that you have the right material that has a high capacity for CO2, can easily release the CO2 to vertical farming applications, and does it in a stable way, a safe way, and also an energy efficient way. The sorbent material that we use is actually placed in our filters. And these filters are really an important part of Skytree technology. We actually have a portfolio of patents on filter technology. The filters we have developed for direct air capture, and they make sure that we have a really low energy consumption for the CO2 that we capture and produce. Now, this is part of all the work that we've been doing in the research and development team, but this is not all that we've been doing. We have been looking at the sorbent materials, yes, but we've also been looking, for example, at the lifetime of these sorbent materials. Naturally, if you buy Skytree technology, you want to make sure that it keeps running for a long time because you want to have a stable supply of CO2 for the plants. This is why we've been looking into factors that affect the lifetime of the sorbent materials as well as the filter and the technology as a whole, and make sure that you have a long lifetime of the technology. We're also looking at global operating performance of our technology. This means that we know exactly wherever we place our technology in the world, that we can always deliver the highest performance, which means a high capacity at a low energy consumption. Now, we do not do this by ourselves. We also have a lot of external parties that we work with together. So we have a lot of people in the research and development team here, but we work together with universities, with research institutes, and as well with other small or medium sized enterprises to make sure that we have the best technology for now, in the future, as well as integration with whatever application is good for the CO2. Based on this research, we have identified some of the main challenges that remain for direct air capture. The main challenges are making sure that you always have the highest CO2 capacity at the lowest energy consumption, and of course with as low as a carbon footprint as possible. Based on the extensive knowledge, years of research, and all the data that we have acquired, we've been able to build very sophisticated models for all of these different topics. So we know wherever we put our technology, for whatever the application is, that we always deliver the best CO2 solutions for our customers. It might be nice to actually zoom in a little bit more from the carbon footprint that we have analyzed for our technology. And this we do through life cycle assessment. This does not only look at the carbon footprint, but it looks at all the environmental footprints that our technology has. For example, land use or safety in water. This is also reflected in the ESG reporting that we do as a company to make sure that you always have the greenest supply of CO2. And with that, I'll hand it back to Camille, who will happily answer some of your questions.